So here we have 4 points P1, P2, P3 and P4 lying on the plane with O being the origin of vector. We need to show that the point P4 coincides with the origin O if and only if this particular criterion is met. Now let's try to understand the problem graphically first. So here what we'll do, we will be considering 4 points. So let's say we have point P1, P2, P3 and P4. So these are the 4 points, and then we're going to consider a point O, which is going to be the origin of vectors. That means if we draw a vector joining point O and P1 and another vector joining O and P2, O and P3 and O and P4, then they are going to have a common initial point, and that's going to be the origin O. Now, in order to prove this problem, what we'll do, we'll begin by first considering the point O, P1, P2. We'll be joining P1 and P2, and let's say we have a vector going from P1 towards P2. Now in this triangle O, P1, P2, we're going to apply the triangle law of vector addition. First, we're going to consider the triangle O, P1, P2. Now here, we'll start with the vector O, P1, and then we are going to add it to the vector P1, P2. So the sum of these two vectors is going to give us the resultant vector, which is going to be the third side of the triangle OP2. So we have OP2 vector, that's the resultant of the sum of OP1 and P1, P2 vector. So let's name this as number 1. Next, what we'll do, we'll go to another second triangle OP2, P3. So for this, we're going to join P2 and P3 with a vector that goes from P2 to P3. Okay, so here we have in triangle O, P2, P3. So we'll start with the side O, P2. Then we're going to add it to the side P2, P3. And then this will be equals to O, P3. Fine, so let this be number 2. And then we're going to consider the triangle that we have in the triangle O, P3, P4. So we're going to join the points P3 and P4 with a vector directing towards P4. We have in triangle O, P3, P4. That's going to be the vector sum of OP3 added to P3, P4 equals to OP4. Fine. Now that we have equation 1, 2 and 3, what we'll do, we'll take equation 1. So here we have OP2. We will be substituting this value into the first term or the first vector OP2 in equation number 2. So we now have equation number 2 transforming into, we have, so in place of OP2, we'll be placing OP1 vector added to P1, P2 vector plus P2, P3 vector, and this will be equals to OP3. So now that we have OP3, we're going to replace this OP3 in the first vector of equation number 3 to get, so equation 3 is now going to become OP1 vector added to P1, P2 vector plus P2, P3 vector. Then we have this P3, P4 vector, P3, P4 vector, and since we are working with number 3, on the right hand side we have OP4 vector. Okay, so this is the equation that we will be working with right now. Now, in order to show that point P4 coincides with O, then it is necessary that this equation, that means there's a sum of these 4 vectors must equate to a 0 vector. Now here for our equation, let's name as number 4. In equation number 4, the left hand side matches with the original expression. So that means here, let OP4 vector, let this be equals to the null vector, the 0 vector. If OP4 becomes equals to 0 vector, then this simply means that the distance, or that means the point O and P4 are coinciding. That is why there is no vector lying between OP4 vector. It's simply a 0 vector. So this implies that P4, the point P4 coincides with the origin of vector O. So we have successfully proved the problem.